Hello, how to solve this problem? We have n times n times n, and this equals 27 divided by 8. We are solving for all values of n that satisfies this equation. So let's multiply this out. N times n, that is n power 2 times n. This is n to the power of 3. And this equals 27 divided by 8. So if you copy out this 27, you have 27 equals 3 times 3 times 3. And this is 3 to the power of 3. And also, if you consider 8, you have 8 equals 2 times 2 times 2. And that is 2 to the power of 3. So let's replace 27 with 3 power 3 and 8 with 2 power 3. So we are going to have n power 3 equals 3 power 3 divided by 2 power 3. Now let's consider this order identity. If you have a power c divided by b power c, this equals a divided by b all to the power of c. So we apply this identity right here. We are going to have n power 3 equals 3 divided by 2. This is raised to the power of 3. So we can move this over here and equate everything to 0. So what we are going to have will be n power 3 minus 3 over 2 raised to the power of 3, and this equals 0. So right now, this is to the power of 3, this is to the power of 3, and there's minus sign here. We can consider this cubic identity. If you have a power 3 minus b power 3, this equals a minus b times a squared plus ab plus b power 2. So let's consider this right here. That means we are going to have n minus 3 over 2 times this will be n power 2 plus n times 3 over 2 plus 3 over 2 to the power of 2, and this equals 0. So from here, we have n minus 3 over 2 times this is n squared plus n times 3, that is 3n over 2 plus 3 power 2, that is 9 divided by 2 power 2, that is 4, and this equals 0. So right now we can equate each of these to 0. We have the first one, n minus 3 over 2 equals 0, or we have on this one here, that is n squared plus 3n over 2 plus 9 over 4, and this equals 0. So let's solve each of these equations. Let's concentrate on the first one here. We simply move this over here. We have n equals 3 over 2, and this is our n1. So we have gotten the first real solution. Let's consider this quadratic equation to find the other values of n. I'm going to copy out here. I have n power 2 plus 3n over 2 plus 9 over 4 equals 0. This over 1. So we find the common LCM, that is 4. Then this 4 will divide 1, that is 4 times n squared, that is 4n squared, plus 4 divided by 2, that is 2 times 3n, that is 6n, plus 4 divided by 4, 1 times 9, you have 9. This equals 0. So we can decide to cross multiply. This is about 1. We cross multiply. The 4 here will multiply the 0 here, and this will multiply 1. So from here, what you are going to have is 4n squared plus 6n plus 9. This equals 0. Then if the 4 multiplies 0, you have 0, right? So we have this quadratic equation. Now, we are going to solve this quadratic equation using the formula method. So let's write the formula in respect to n. We have n equals negative b plus or minus square root of b squared minus 4 times ac divided by 2 times a. So the 4 is our coefficient of n squared, that is our a. The 6 is my b, and 9 is my c. So let's insert it right here. I'm going to have n equals negative p, that is negative 6, plus or minus square root of b squared 6 power 2 minus 4 times a, that is 4 times c, that is 9, divided by 2 times a, that is 2 times 4. From here, I have n equals negative 6 plus or minus square root of 6 power 2, that is 36 minus 4 times 4, 16. 16 times 9, you are definitely going to have 144. So this is divided by 2 times 4, that is 8. So from here, we are simply going to have, this is n equals negative 6 plus or minus square root of 36 minus 144. This is negative 108 divided by 8. And from here, we have n equals negative 6 plus or minus square root of this minus. Here we have square root of 1, negative 1 times, because of this minus, square root of 108 divided by 8. And from here, we have n equals negative 6 plus or minus square root of negative 1 is I times square root of 108. We can express it as 36 times 3. And this is divided by 8. So from here, we have n equals negative 6 plus or minus I times square root of 36. This is 6 times root 3 divided by 8. And from here, we can have 2 divide this, 4, 2 divide this, 3, 2 divide this, 3. So what we can have is n equals negative 3 plus or minus I times 3 root 3 divided by 4. So from here, we can have n equals this factor of 3 over 4. Factor over 4, negative 1 plus or minus I root 3. So we have two values for n. We have n2 equals 3 over 4 times negative 1 plus I root 3. And also, we have n3 equals 3 over 4 times negative 1 minus I root 3. So these are the two complex solutions for n. Now we have one real solution for n, which is this particular value here, 3 over 2. So what we can do is to insert this 3 over 2 back into the original equation, and let's check if it's going to satisfy the equation. So you have check. We have n equals 3 over 2. So I have n times n times n equals 27 divided by 8. So we have this is 3 over 2 times 3 over 2 times 3 over 2 equals 27 over 8. So from here, we have 3 times 3, 9, 9 times 3, this is 27 divided by 2 times 2, 4, 4 times 2, 8. And this equals 27 divided by 8. Left hand side equals right hand side. So that is it. Thank you and see you again. Don't forget to subscribe and share this video to your friends. And kindly leave a comment on the comment box, guys. So I will really appreciate that. Then if there's any question, you can drop it down in the comment box. I will gladly attend to it. So that is it, guys. Thank you.